Okay, guys, so these are the answers to your homework assignment. If you got any of them wrong and you want to know why, I posted another Edpuzzle. Hopefully I posted. And it shows you each problem and how to do it. You can pause it. You can skip through them to only get to the problems that you need help with. And hopefully that gives you some clarity on where you went wrong. Now we're going to go through a 3-equation system. So basically, a 3-equation systems, you're using systems multiple times. I would say probably 4 different times you're going to use it. So you might use elimination 3 times. You might use your substitution once. It's going to be using elimination a few times. It is tedious, but it is something that's good to know. I want to give a quiz next Monday just so we can get it over with before winter break. We'll see if that happens. We'll discuss in class Wednesday, Thursday, see how we're doing. But that is my goal, and you will have one type of problem like this. Once again, if this is too confusing, too hard for you, I want you to put it on the Google form I'm going to post later and tell me this is a struggle, and we will go over it Wednesday, Thursday again to help you a little bit more. But it is what we've been doing with systems, just a step up, like I said, doing it a couple times. So for the first problem, we see, okay, look at all the coefficients. Which variable has a coefficient in front of it that's 1? Okay, z. So I'm going to try to eliminate z because I want to get a regular, I'm putting that in air quotes, a regular systems problem with 2 variables. So I'm going to try to eliminate z from all equations to get 2 variables with 2 equations. So we're going to multiply this one by 3 so we can get rid of the z. So if I multiply this by 3, I get 6x. I'm going to write it up here. Minus 9y plus 3z equals negative 48. Now we add. 3z's go away. This becomes 11x minus 11y equals negative 55. So that's just one of our normal systems problems. And we're going to do that again with this equation and the other to get rid of the z values. So instead of multiplying by 3, I should multiply by 2. And if I do that, I get 4x minus 6y plus 2z equals negative 32. So this becomes, when I add them, 7x minus 2y equals, we'll do negative 32 plus 7, which is negative 25. And I just canceled out the z's. All right, now we have a 2-variable systems problem. So I can do it by elimination if I want, but for me, I feel like this could be used as substitution. So if I divide everything by 11, I get x minus y equals negative 5. Add y over, and I get x equals y minus 5. So I'm going to take that and plug it in here. So I get 7y minus 5 minus 2y equals negative 25. Distribute 7y minus 35 minus 2y. It's going to happen a lot, and I hate when that happens. Equals negative 25. 5y minus 35 equals negative 25. So 5y equals 10 and y equals 2. All right, we have one of our variables. And if you're confident in yourself, you say, I know I did this right, you can plug it into here and solve. You definitely can do that. But what if you did something wrong? There's always that chance you did something wrong. So I'm going to take 2 of my originals and substitute y for 2. So I'm going to take the first one, 5x minus 2 times 2 minus 3z equals negative 7. And I'll do the next one, 2x minus 3 times 2 plus z equals negative 16. So this becomes negative 4. Add the 4 over, I get negative 3. So 5x minus 3z equals negative 3. This becomes negative 6. Add it over, I'm going to get negative 10. So 2x plus z equals negative 10. All right, do another systems problem. So multiply this by 3, and I get 6x plus 3z equals negative 30. So the z's cancel out. 5x plus 6x equals 11x. negative 3 plus negative 30 equals negative 33. So x equals negative 3. So now I have my x and my y. So let's plug them in and solve. So I'm going to use my second equation just because I feel like that's simpler with my z. So we have 2 times x, I'll rewrite it, minus 3y plus z equals negative 16. Our x is negative 3, so 2 times negative 3 minus 3 times 2 plus z equals negative 16. So negative 6 minus 6 plus z equals negative 16. Negative 12 plus z equals negative 16. So my z equals negative 4. So we put this in bracket. You put your x first, then your y, then your z. So we'll have negative 3, 2, and negative 4. So this might have seemed like a lot, but it's just what we've been doing, using it multiple times. So if you need to rewind this at any point, if you want to refresh it between now and Wednesday, email me. I can send you the YouTube link to this and we can work on it together. All right, so I want you to try this one. Try it. I'm going to pause it here so you can give me your answer. Try it on your own, and then we'll try it together. All right, so let's take a look at it together. So if I look at this, I say the x's are going to be the easiest to get rid of. If I look at the first two, I can just add them and then get rid of the x. So if I add these, x goes away. So I can rewrite this to make it easier for everyone. And I have negative x plus 3y minus z equals negative 6. So I add them. This goes away. This becomes y plus 2z equals 3. Now let's look at the next two equations. You're going to multiply this by 2. And I get negative 2x plus 6y minus 2z equals negative 12. X's go away. I'm left with 6y minus 5y, which is y, plus 3z equals 5. All right, I can easily solve these by subtracting. So this becomes y goes away. Negative z equals negative 2. So z equals 2. All right, not bad. Now I'm going to use the first two equations. X minus 2y plus 3 times 2 equals 9. Negative x plus 3y minus 2 equals negative 6. So 6 minus it over is 3. So I get x minus 2y equals 3. Negative 2 added over is negative 4. So negative x plus 3y equals negative 4. Add these together. We get y equals negative 1. All right, let's plug it into our original easiest one. I think the second one's the easiest. So negative x, we don't know what that is, plus 3 times negative 1 minus 2 equals negative 6. So negative x minus 3 minus 2 equals negative 6. Negative x minus 5 equals negative 6. Add 5 over, we get negative x equals negative 1. So x equals 1. So my answer would be 1, negative 1, and 2. I know I went through that a little bit quickly. So if you need to go back, like I said, if you need a YouTube video of the link of it to go over it again, that is perfectly fine. And we'll look at it again Wednesday and Thursday. I have some more problems for you guys, all right? So let's look at graphing. So if you were to graph the equations of no solution, what do you think it would look like? Answer that question for me. No solution means they don't cross ever. When lines don't cross ever, that's going to be parallel lines. Any two lines you have are going to cross at some point somewhere unless they are parallel. Infinite solution, what do you think the graphs would look like for that? They would be the same line. They would be one line that's the same. Same exact equation, because any point will be the same on both lines. They're the same exact line. All right, so let's look at systems graphically. So we want to use the graph to solve the systems, and check algebraically. So we said that to graph systems to see where the solution is where they intersect. So they intersect here, which is 3, 2. And we can check. If I plug in 3 plus 2 times 2, that's 3 plus 4, which is 7. 3 times 3 is 9, minus 2 times 2 is 4. 9 minus 4 is 5. So you're good to go. So now we're going to create our own graphs. So I want you to follow along with me on Desmos if you can, and we're going to try these together. So we have to first always find the slope-intercept form of both of these equations and graph to see the intersections. So I know graphing is tedious sometimes, but it is important to be able to graph these and see the intersection. And you will have some problems like these on the quiz. So to get this into slope-intercept form, we add the x over. So we have y equals x minus 7. For this one, we subtract the x over. And we divide by 4. So negative 1/4 x minus 2. So let's graph them. I'm going to graph y equals x minus 7. So that means we start at negative 7. 1, 2, 3, 4, 5, 6, 7. Then we go positive, up 1 over 1 over 1. As you can tell, it's just the corner of all these boxes that you will line up. And you have to keep going because we don't know where they're going to intersect yet. So if I stopped, let's say here, well, what if they intersect up there? And you should draw your line connecting, try to make it as straight as possible. I know it's hard online. And then negative 2. Then we go down 1 over 1, 2, 3, 4. Oh, look, we found our point. It just makes sense to do like at least one other point other than the intersecting one in the y-intercept. And then we can cross them together. So our answer to this would be 1, 2, 3, 4, 4, negative 3. If they don't intersect, obviously it could be an infinite or no solution, but a lot of the times, if I give you a graph, it's going to intersect. So it'd be 4, negative 3 as your final answer. And you can check to see if that's correct. You could plug it back in and see if they both work. And also, like I said before, I won't give you one that's infinite or no solution. But if I give you one that's infinite solution, it's going to give you the same equation. If I give you one that's no solution, it's going to be the same slope but different y-intercepts. So you should know that automatically without graphing it. So usually I'm going to give you ones that intersect for that reason alone. All right, I want you to try this one. So I'm going to pause it. I'm going to have you give me the point where they intersect. Try it on your own. All right, let's take a look. So we add 5x to both sides. So we get y equals 5x. We subtract 5x over y equals negative 5x plus 10. So this means we start at an intercept of 0, 0. And we go up 1, 2, 3, 4, 5 over 1. 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 This one we start at 10. And we go down 1, 2, 3, 4, 5 over 1. 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 And we see that our lines, when I draw them, that is not straight at all. Yours should be straight, but intersect at 1, 1, 2, 3, 4, 5. 1, comma, 5. Okay? And sometimes we have seen in the past that when we're graphing and I'm asking you for the y-intercept, the x-intercept, sometimes it's a decimal, so we can't see it on the graph. That might happen in these problems. We're going to see it may happen. So if it happens and it's going to a decimal and I ask you right now for the answer, you're going to put decimal for now. And I'll show you later on how to find those two intersecting lines using graphing calculator. I'll do that on Thursday probably. I don't think on the quiz I will give you one where they intersect at a decimal point. I'd rather give you ones like these that are easy on you guys. So yeah. Let's try this problem and see if it works. All right. Let me clear all this. So this becomes add x to both sides, divide by 2. So as we can see, automatically we're going to have 3/2 x. So this is going to be a little bit weird and probably won't line up as a whole number. So I'm not a huge fan of this one, but as long as you got your graph looking similar to mine, that's all that matters. All right, so let's take a look at this. So this automatically is a little bit weird. I think I might have said this already because we have the 3/2. So we get y equals 1/2 x plus 3/2. And this becomes y equals negative 2x plus 4. So let's graph it. 3/2 goes right here. Up 1 over 1, 2. 1 over 1, 2. Up 1 over 1, 2. Up 1 over 1, 2. Down 1, 1, 2. Down 1, 1, 2. Down 1, 1, 2. Down 1, 1, 2. And we can draw our nice line to connect. Our next one is plus 4, so 2, 3, 4. Then we go 1, 1, 2 over 1. 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 And I can connect it. And when connecting it, we can see that they connect at 1, 2. I know that our point here did not go through it. It's a little, if you plug it back in, you're not going to get 1. For some reason, this is the answer, but I'm not going to give you one like this on the test, on the quiz, excuse me. On the quiz, it's going to be one that is clear as day. This is the right answer. You plug it in, everything goes well. All right, so don't stress about this one. It'd be one like the first or the last one. All right, try this one. All right, let's try it together now. So this becomes y minus equals negative x, minus 5. Nope, it should be positive x. So, wow. We subtract x over, so it's negative. Divide by negative, it's positive. This one should be y minus, I don't know why I keep saying that, y equals negative 3x plus 3. So minus 5 goes down 1, 2, 3, 4, 5. And we go by ones again. And we connect as best as we can. My hand's a little shaky today. The other one is plus 3. 1, 2, 3. So we go down 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And we can connect it. So when we connect it, we have 1, 2, 2, down 1, 2, 3. 2, negative 3 as my final answer. All right. So now let's take a look at some absolute value problems. So I'm going to work on this one with you. We're going to see how this should be attempted. So we're going to act like we are solving absolute value normally. So let's just look at the first one. We know with absolute, or I don't know why I'm saying absolute value. I'm sorry, guys. I normally would re-record this, but I'm so far in that I can't. I'm talking about inequalities. Inequalities, just inequalities. We are going to act like we are normally graphing inequalities. So if I looked at this equation, I would act like it's 2x plus 1, and I would graph it. So we go up 1, then we go up 1, 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, And for these type of problems with inequalities, you have to keep going. You have to continue. And because it's a less than sign, we are going to dash it. All right, now let's graph our next one. Negative x plus 3. So go up 1, 2, 3. And it's a negative, so we're going to go this way. All right, so this becomes a solid line. So now we're going to look. If I look at the first one, the first line, and you could do this separately, I decided to do it together. When I say separately, I mean look at the first line, then shade, then look at the second and shade. I decided to do it this way. So I'm going to shade in red for the ones that's this way. So if I'm saying y is less than 2x plus 1, I could plug 0, 0 in. Is 0 less than 1? Yes. So we're going to shade that side where 0, 0 is. And we're going to do it all around. Doesn't matter that that line is there. Now I'm going to use a different color. I'll use purple. And I'm going to plug 0, 0 in. Is 0 greater than 3? No. So my solution is on this side. So my final answer for the solution of systems is going to be this part here. So I'm going to maybe take another color or make it known that this is my final answer. So I have 3 different colors here. This is my final answer. This part that they both contain. So not down here, not over here. This part that they both contain. All right. And as you can see on that graph, it's there as well. All right, I want you to try this one on your own. Try it for me. All righty. So let's do that one. Let me write it down. When we rewrite that, that becomes y minus 2x. So y is greater than negative 2x plus 4. This one becomes y is less than or equal to 2x minus 1. So let's graph those. Plus 4. 1, 2, 3, 4. Up 1, 2 over 1. Up 1, 2 over 1. Up 2 over 1. Down 2 over 1. And we connect our line. Now the other one, I'm going to, oops, this should be, yeah, that should be solid. I'm going to do the shading now, because why not? So if I plug in 0, 0, is 0 greater than or equal to 4? No, so I'm going to shade in this side. I'll do it lightly just so when I draw my other line, we're okay. We're able to see where the lines are. Well, let's choose a different color. I'm going to choose purple. So negative 1. Then we go up 1, 2 over 1, 1, 2 over 1, over 1. And it's a solid line again. All right, plug 0. Let me make this line better so we can see where 0, 0 is. Plug 0, 0 in. Is 0 less than or equal to negative 1? No, so we're going to shade in this side. So our common area is the place where you see the blue and the purple. So this part here would be our answer. And like I said before, you can shade it in with another color if you want to. So I can say, all right, that's my answer. And that might help you. All right. I want you to try this one. Try this one, and then we'll go over it together. Alrighty, so we are going to go over the last one here. For some reason it all exited out, so we had yellow, so x is less than 2, y minus x is less than 2, so this becomes y is less than x minus plus 2, x plus 2. Alrighty, so let's draw these. So x is less than 2 means a 2 here. So we do a dashed line, nice dashed line because it's less than, not less than or equal to. And we put our arrows to say we're continuing. X is less than 2 is a shade this way. And then we are going to do our next problem. I will put it in a different color. I'll choose red. X is less than x plus 2. So we go up 1, 2. We go up 1 over 1, 1 over 1. And keep on going. Alright, and because once again it's going to be dashed, so I'm just going to quickly go through with some dashed lines. Not bad, going quickly. Alright, so plug in 0, 0. Is 0 less than 2? Yes, so we shade this way. We shade this way. We have all this part here, obviously, but we can tell that right here is where the combined is. So once again, you could do a different color if you want. If we were in person, if everyone was in person, we would have it on graph paper and you would darkly shade in this part, lightly shade in the other two sides, but we're not, so that's what we're working with. All right. I want you to try this one. Try this one on your own and then we'll discuss together. All right, so this becomes y is less than, because remember we have, when we divide by negative, we switch the signs. 3/5 x plus 2, and this is y is less than 2x minus 5. So this becomes 3/5 x plus 2, so plus 2, up 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. And we have some dotted lines. Like I said, I'll do that quickly. If I plug in 0, 0, is 0 less than 2? Yes, so it's going to be shaded down here. And then if I use another color, -5, so down 1, 2, 3, 4, 5, up 1, 2 over 1, 1, 2 over 1, 1, 2 over 1, over 1. Down to, so it is important that we shade in the whole thing, because like you see, we have to shade everywhere. So plug in 0, 0. Is 0 less than -5? Nope, so we have to shade on the opposite way. So we shade down here. And that would be our combined area. That's all by itself. This would be the combined area. And that's right. All right, try this one. I'll write it over here. Try that one. All right, so x is greater than 5. 1, 2, 3, 4, 5. Dashed line. Greater than 5 goes this way. Y is less than or equal to 4. 1, 2, 3, 4. Dotted line. Less than or equal to goes here. So my proper answer is right over here. And that combined area, which just shows final one. I'm not going to make you do it's all these types of fractions, and I don't like those fractions. The second one becomes a huge fraction. So hopefully you're able to understand these. If you have completed all of this, you can start your homework if you have time. I also want you to fill out that Google form to me so I know what I need to work on Wednesday and Thursday. Wednesday, we are going to go over some word problems using systems. So you're going to have to create them and solve them. And then Thursday, we'll do a review before your quiz. So once again, if you're so lost with all this, please email me and I'll see you Wednesday and Thursday.